Hello, in this video, we're going to have a look at tangents and normals, which are kind of an application of um, looking at the gradients of functions. So we'll look at tangents first, and really a tangent line comes from basically the way we worked out what the instantaneous rate of change was in the first place, if you remember, which was looking at average rate of change and then bringing the 2 points closer together, and we get a straight line with a gradient. We sort of said the gradient of that straight line is also the gradient of that point on the function. So a tangent is basically that. It's kind of like saying, well, if we can work out the gradient of that function at a particular point, then we can draw a straight line with that same gradient and passing through that point. And this is basically what this says. Tangent is the linear equation with the same gradient as f of x at a given point. What I didn't write here, but is absolutely critical, is it's the linear equation goes through that point as well. So here's a point on this old cubic graph here. And if I draw it nice and neatly, wish me luck. Oh, that was pretty good. We can see we've got a straight line like so. It passes through that point. It tends to kind of kiss the graph and then keep going. And the gradient of this straight line will be the same as the gradient of that point. So let's go straight into a couple of examples. And I'll warn you now, I'm going to go through a couple of examples. They're pretty straightforward examples. In the textbook, there are lots of complicated examples. I don't think the concept's too hard, but how you apply that is where it gets a bit tricky. And I think you just need to go through a whole bunch of examples in the textbook and get a feel for it and ask me questions as we go along. So this is basically, here's the technique, but now see lots of different situations in the textbook. Okay, so we're told f of x equals 2x squared plus 12x plus 7, and we're asked to find the tangent at x equals 1. Now remember what I said before, we need to know what the point is where the graph is going to go through. At the moment we haven't been given a point, we've just been given an x coordinate. So we need to work out the y coordinate first. So we can say that y, so this is the solution, the start of the solution, y is equal to f of 1, which is equal to 2 times 1 squared plus 12 times 1 plus 7. Wish me luck that I can do this in my head. 2 times 1 squared is 2, plus 12 times 1 is 12, so that's 14, plus 7 is 19. No, told you I couldn't do it in my head. I'll do for Sana. Let's try that again. 2 plus 12 is 14, and 14 plus 7 is 21. That sounds a little bit more like it, doesn't it? And so we're asking to find the tangent that goes through 1, 21. Okay, let's now work out what the gradient of that function is at 1, 21. To do that, we need to know the gradient function. So we find the derivative of f of x. So f dash of x equals, pause the video if you want to, try and get ahead of me. Or put me on slow motion, and then you can get ahead of me. Either way, we're going to end up with 4x plus 12 as the gradient function. Lovely. And we're interested at what the gradient is at x equal to 1. So I'm going to substitute in 1 for x here. So it's 4 times 1 plus 12. And that gets me 16. The gradient is 16, and we have a point 1, 21. So with a gradient and a point, we can now use our linear equation understanding in order to work out the equation of the tangent. You can use y equals mx plus c. You can use whatever method you'd like to, really. But I'm going to use this one here. I'm going to use y minus y1 equals m outside of x minus x1. I use it because I know what y1, x1 is, and I know what m is as well. So why not use it? So therefore, tangent equation is, here we go, y minus, what was it, 21? Y minus 21 equals gradient 16x minus 1. Okay, so that means, I'll go on to slide 4, might as well. So that means that y minus 21 equals 16x minus 16. And I'm going to add 21 to both sides to get y is equal to 16x plus 5. And that's it. I could have left it, by the way, at this point here. This is a legitimate way of expressing a linear equation, but I kind of prefer to have it in y equals mx plus c format. So there it is, y equals 16x plus 5. One more example and that'll do us, and that's looking at normals. Now, I just need to explain to you what a normal is, I suppose. I'll just zoom up so we can sort of see this. I've got some words here to put to it, but if we've got a function like so, and we have a tangent line here, which is the line that sort of has the same gradient, what we talked about a second ago, then the normal is simply the line that goes at right angles. This is frequently used in places like physics where you want to know the force that would need to be applied in an opposite direction kind of to something that's happening in this dimension instead. So this is called the tangent, this is called the normal. So it's at right angles. And you might remember that at right angles is perpendicular, and we have a little bit of a rule, I suppose. M1 times M2 equals -1, or the gradient of the tangent multiplied by the gradient of the normal has to equal -1 for them to be at right angles to each other. So we can use that. And I would never actually do that. I mean, sometimes I would, but more or less, I wouldn't bother doing that for the most part. I would simply find the gradient of the tangent, and then I would flip it and change the sign. So if the gradient was 7, the gradient of the normal would be 1/7, but then make it negative, so -1/7. Okay, so here we go. We've got an example. Find the normal of f of x equals x squared at the point 2, 4. We're given the full point this time, so we're all good. We start the same way. So the solution is exactly the same process, and that is we find the derivative, and that's equal to 2x, and we substitute in the x coordinate to work out what the gradient is at that point. F dash of 2 is equal to 2 multiplied by 2, which is equal to 4. So we've now got our gradient at x equal to 2. Now we want to find out the normal. So if mt is equal to 2, then the normal gradient is equal to -1/2. Okay, so 2 has been flipped to a half. 2 is 2 on 1, flip it to a half, change the sign, so it's -1/2. If you want to, you could just multiply them together and then work out what mn is from there. So we've now got our gradient, and now now that we've worked out the new gradient, the rest of it is actually the same as well. Again, I'm going to use the point gradient form. So y minus y1, which is 4, we're told that in the problem, is equal to gradient minus a half, x minus 2, the x coordinate, and now I'll just tidy that up. So y minus 4 is equal to minus a half x plus 1, minus a half times minus 2. And I'm going to add 4 to both sides to get y is equal to minus a half x plus 5. And that's my normal equation. Okay, so go to the textbook, try as many examples as you can. There are some trickily worded questions. It's worth persevering with these and asking lots of questions and determining exactly what it means so that you can't be caught on the hop. But at the end of the day, they all come down to, do you need to work out the tangent, or do you need to work out the normal, or a line that's parallel to the tangent, or a line that's parallel to the normal? But this basic process is always where you start, and then you sort of build from there. Good luck.